Welcome everyone. So I just want to quickly introduce myself. So my name is Anna-Marie Gillespie. I'm the organizer and the co-host of this webinar. I'm a business development manager at ETP, and as I'm a shared resource, I also work for Construction Scotland Innovation Centre as an impact manager within their sustainability team. So we have a fantastic set of speakers today covering various topics around heat pump retrofit. And I would like to thank them for giving up their time today. So just a bit of housekeeping. So if you could just keep your cameras off and microphones muted. And if you have any questions at all to the presenters, you can either post them in the chat box or you can ask at the end of the webinar during our Q&A session. And also to note that this webinar is recorded. So I will now pass on to our chair today, John Gilbert, Professor of Thermal Energy at University of Glasgow. Over to you, John.
Thank you very much, Anne-Marie, and thanks to all speakers and the audience. Thanks for participating in this wonderful session. So just a quick word. So we are now in the process to reach net zero. So in the UK, the government set a target to reach net zero by 2050. In Scotland, the target is even earlier, 2050. If we look at the energy consumption and heat, accounts for about half of the heat consumption, and so decarbonizing heating sector is particularly important for us to reach the net zero of greenhouse gas emissions by the right time. And so today, for this reason, today we organize this session between ETP and the University of Glasgow to talk about how heat pumps, particularly in the context of a retrofitting in Scotland, because in Scotland, more widely in the UK, we have a lot of historic houses, all the houses. If we want to use heat pump for decarbonizing our heat supply, so they have a particular set of challenges. And today, at this particular session, we will look at from different perspectives, from the manufacturer perspective, from the state of the art of the heat pump heating technologies, and from the architecture perspective, and from the historic perspective, et cetera, and et cetera. So we will look at this particular challenge from different angles and to try to stimulate the discussion and also try to explore opportunities for collaboration, as Anne-Marie highlighted at the beginning. So the main objective, one of the main objectives of this particular session today is to really network with each other and to explore opportunities for collaboration in the future. And I would finish here and then start to introduce the speakers. But before that, I would like to say heating or heat pumps is a very hot topic at the moment, but also it is a very cool topic to talk about it today. So I hope you all will enjoy this session. And so we have a list of very good speakers today. So I will introduce one by one, and each speaker will give us a talk for about 15 minutes. And we will not have gaps between presentations, but we will leave about 10 to 15 minutes at the end for the audience to ask questions. I hope this is okay. And so our first speaker is Barbara Lantschner. She is our Associate Director and of the John Gilbert Architects. So Barbara will talk about the retrofitting heat pumps. So Barbara, the floor is yours.
Great, thanks very much for that introduction. I will now try to share my slides. Can you see that? Okay.
Yeah.
Great. So very quick introduction about myself. I am an associate director at John Gilbert Architects. We're based in Glasgow, and my role in the office is I mainly work on retrofit projects. So we've seen lots of existing buildings and retrofitted and evaluated lots of existing buildings across Scotland and England and the UK, specifically Scotland and the Central Belt, but we have done works in the highlands and islands and etc. So my what I will try to briefly talk in the next 15 minutes, it's what we have found and how retrofit is linked to the universe of zero carbon technologies and on zero carbon targets. So very briefly on the context that we are currently, the existing Scottish context. So what you probably all know, it's a big proportion of the Scottish homes today are still falling under band F or G. The graph that you saw seeing on the right, it's the source of that graph is the Scottish government, and the graph is from the Scottish Housing Condition Survey in 2019. So that might have changed slightly, but not radically. So what you see there is that a big proportions of the existing stock, it falls under F and G, mainly pre-1919 properties, off-grid or all-fueled properties, private rented properties, detached, semi-detached, and tenements. So we'd like you to keep that in mind for the next slides to see where the problematics are and how our heat pumps, how can we improve these conditions with heat pumps, and which are the main challenges. So another point that I wanted to highlight is that this information, and most of the information that you're going to see on existing buildings, it's based on SAP and RDSAP methodologies. Probably most of you know what SAP is. It's the Standard Assessment Procedure. So it's the main tool chosen by the government to establish how energy efficient and existing or new build is. In this case, existing. These tools are great. They are giving us a general idea of how homes are performing, but they are not necessarily accurate, and they're based on assumptions just to have good and well, it's for good reasons. They are based on assumptions, but they are not sufficient for us to understand in depth how properties perform and how much money are also tenants and occupiers paying on their fuel bills. So this sometimes leads to performance gap issues. So reality and predicted values given by SAP are don't always match. And it's good to keep that in mind. That doesn't mean that SAP it's wrong or we don't have to use it. It's just that we might have to consider that when we are preparing retrofit strategies or when we are trying to improve the existing stock. So zero carbon energy will ultimately be delivered by electricity grid. And we need to retrofit our buildings to make sure that heating and hot water run on electricity. So we do know those things. We know that we have to improve buildings, that many existing buildings are not efficient, a good proportion of them. And we know that we have to change systems to make them run on electricity. So how is deep retrofit and retrofit strategies how are they linked to this? Well, the first thing that we also know, what I was mentioning before, that performance gap issues are endemic. So that means that the graph that you've seen in the last slide probably could be even worse because SAP is not necessarily accurate. That means that many properties that are in theory A, B, or C, have an APC of A, B, or C, might actually not perform as good. So it's good to keep that in mind. And it's good to understand how important deep retrofit strategies are to try to minimize that gap. Some of the standards which are trying to minimize that gaps in the retrofit industry are PAS 2035, EnerFit, the AECB carbon light standards, and many others. So I invite you to look at those standards to minimize this gap. So we do know that existing buildings can be not efficient. And so how is this linked to heat pumps? If a building is not very efficient, something that we know in order to the heat pump to provide a low cost to be affordable to residents, what we will need to do is to improve the fabric of that building before considering systems improvements. So heat pumps require lower floor temperature. If heat demand isn't reduced, so that means if the fabric is not improved, then energy bills can increase. So if we don't improve the fabric before we think of a system improvement or replacement, that means that we are there might be an increase of fuel bills, and that will affect residents and particularly people under fuel poverty conditions. So the key strategies for a successful retrofit, and that includes heat pumps, it's first, and step number one, that's in order, look at the fabric first approach to reduce the space heating demand as far as possible. It depends on the archetype. Sometimes it's easy, sometimes it's a big challenge. The second one is to remove fossil fuel heat sources and replace with low carbon options. One of them, and probably one of the best options, it's our heat pumps. So that's what we're talking about today. And number three, it's to generate renewable energy. So once we have upgraded the active systems, we can look at renewable energy systems and see how that's linked to the fabric and to the active systems. And the graph on the right shows how crucial it is to look at deep retrofit strategies to actually meet that CO2 emission target that the government has set and Europe has set. So we can meet that 70% reduction target by implementing deep retrofit strategies, not by only looking at improving isolated systems. This is an example of a property that I have visited recently. We visited a lot of properties. That's a big benefit of working as an architect and as a retrofit designer, is that you get to see properties and how people live. Unfortunately, in this case, as you can see in the picture, there's mold growth in coincidence with a very bad thermal bridge. This property had been fitted recently with a new heat pump, with an efficient heat pump. I'm putting this an example, not to say that heat pumps are bad and heat pumps are causing this issue. I'm saying that we first have to address fabric issues and we have to implement a fabric first approach before we look at the systems. So what are the opportunities and challenges for heat pumps and retrofit? I'll try to focus on what we know as architects and we know in the practice. I'm sure that the next speakers will be able to go in more depth on these points, but I'll try to cover what we have seen. So most people agree that the vast majority of homes, vast majority of homes, heat pumps are the main viable option to decarbonize and achieve climate change targets. That's how we see things in the office, and that's what many specialists agree on. There are other ways of decarbonizing, but heat pump, it's one of the most robust ways of doing it. Heat pumps are very efficient in practice. That means that predicted and real data many times meets, but that is if they are designed and installed properly. So I want to highlight that they need to be carefully designed and installed. They also achieve high standards, for example, passive house, which is a good thing and a good sign that the systems are actually robust. They provide low running cost and high comfort levels, again, if designed and installed properly. Challenges. So those 3 points to me are huge. They're really good, because if you see how, not because there are only 3 points, I'm saying that there are not many pros and opportunities. I think those 3 points are great, and heat pumps are great, but there are also challenges. The capital costs are higher if compared with other systems, but then running costs are lower. So and in a world with increasing energy and fuel prices, that's a very important aspect. There are planning restrictions, and we are living that on a daily basis. And I think there should be a compromise with different councils to understand the importance, how important heat pumps are, and try to see how to balance heritage and energy efficiency. But I'll let Prof Ken Gibb to talk about more about that. Building form archetypes might limit the design and installation of this kind of systems. But they can be, but there are solutions to that. So it's very important to analyze this on a very early stage. We also have seen that in the industry, there's a general lack of knowledge on installation skills, but there are very good professionals around there, manufacturers, for example, the other guest speakers, and I'm sure they will also disagree on this as well. But what I'm trying to say is that it's important to qualify people and to mitigate this performance gap issue. Clients and building users don't generally know the system, and it's good to take that into account when you are designing them and address them with quick start guides and better communication. RDSAP not always accurately models the systems, so the results are always not always positive in RDSAP and SAP. So it's also good to keep that in mind. And it requires disruptive internal works, which can be a problem if the properties are occupied. The next 3 slides, I'm going to briefly go through systems that we have analyzed in the office. That doesn't mean that these are all the systems. I highlighted the ones that we haven't analyzed, that we are currently analyzing. So the first option is to have a heat pump that provides both heating and hot water. In the office, we have looked more at air source heat pumps, not necessarily because they're better, but because they are more feasible for the areas that we are working on. But we are currently working on many projects with ground source heat pumps, so it's also a feasible system. In terms of cost, they're higher than other systems, and air source heat pumps generally have a lower capital cost than ground source heat pumps. The efficiency is high, and running costs can be low if designed correctly. COP is from 2.5 to 3, depending on the water temperature. In terms of space requirements, it's important to keep in mind that thermal store requires a good amount of space, and that for existing properties can be a headache. So it's good to discuss that with the client and visit the property as soon as possible to allocate a space for that. And air source heat pumps require an outdoor unit, not ground source heat pumps, which can be a problem depending on the area for planning conditions. In terms of installation requirement, if it's a wet systems are familiar to installers, so that's a good thing. They know part of the system, but they might not know all of it, and there are myths around systems being noisy or not very comfortable, and I think that's that's a myth, and that's systems not being accurately or well installed. The impact on PHEB is good, and that shows that the systems actually work well and are efficient. The second system that we have looked at, it's a compact unit that so a smaller heat pump that uses heat and exhaust air from the MVHR system. We have many of our designs include MVHR, and that provides heat from both space heating and domestic hot water. And the space heating is delivered via the MVHR supply, so via hot air. So this is a system that we are trying to specify for some of our projects and can be more disruptive. So it's better to consider the system if a deep retrofit, a more disruptive retrofit, it's planned, which is sometimes the case. So in terms of capital cost, it could be lower than air source heat pump, but it's generally similar in terms of the efficiency. Can be slightly more efficient than an air to water system, and it fits better to passive house projects. Why? Because they have a more efficient fabric, but in general, they are slightly more efficient. Domestic hot water heating efficiency is not as good as a normal air to water system. And in terms of comfort, it can be a problem because it's difficult to zone and difficult to control because it's the heat is provided with air. In terms of space requirements, it's similar. The unit is slightly more taller than a water tank. So it needs to be addressed or considered at an early stage. Insulation requirements are you need less insulation than other heat pumps. And in terms of installation, installers are not used to these systems, and that also needs to be considered. The last type of system that we have looked at, just to give you an idea that it's not only about full space and domestic hot water systems, it's a system that it's hybrid, so not fully heat pump, but it's a direct electric heating, and where space heating is provided by electric and domestic hot water provided by an air source heat pump. In terms of capital cost, it's generally lower because it excuse me, it only covers domestic hot water system. But it can be a risk because the heating is not as efficient, and that means that the fabric needs to be, we have to ensure that the fabric is highly insulated. I'll jump to my last slides that just to wrap up my presentation and to give you an example of how this can be implemented to a real case. So this is Nature Road. I don't know if you heard of the project before. It has had a good amount of media. Dr. Ken Gibb is involved in this project, so he might be able to mention this later. So in terms, the project is located in Glasgow. It's still on site, and what you're seeing on the right is a very traditional Victorian sandstone tenement. Owned by Southside Housing Association. The original brief was to go meet EASH 2 and beyond. So as a practice, we proposed Enerfit because we knew that that would be the most robust way of going beyond EASH 2. The building consists of 1 close, 8 flats, which were fully owned by the housing association. So we knew that works could be more extensive. Project is funded by Southside Housing Association. Partners are shown there. So one of the big challenges was that these existing buildings are not very leaky, actually. The existing air tightness level is very high. We measured it and it's around 13, 15. Walls were insulated, suspended floors were insulated, so very leaky and not very well performing. So the pros were that, or still are, that 100% of the properties were owned by the clients, so no mixed tenure, nothing. So we had full control over the close. The challenges is that the fabric was very inefficient, and we talked about that before. That's a problem when concerning heat pumps. It had very big limited internal space, so it was very complicated to fit systems to this. And planning, there were many planning restrictions for the front elevation and also for the rear elevation. So that was also a problem when considering systems. PV systems were not feasible, so that was also a problem. So lots of limitations, actually. But we managed to overcome these problems, and we proposed a highly efficient fabric. I'm not going to go into details of the fabric proposals, but what I can say is that the fabric meets NFIT. It's now almost fully installed. They're currently installing systems. And when we were designing this, we took that into consideration. We modeled all the options with PHPP. And we looked at different strategies to improve for low carbon technologies. Unfortunately, because it's a tenement and because space is restricted and surrounding space is restricted, we didn't have many options for systems. And we finally installed air source heat pumps in the ground floor and the first floor, because we were not able to fit outdoor units in the upper floors because of planning restrictions. And there are other systems. We're also fitting MBHR systems and wastewater heat recovery systems. Unfortunately, we were not able to install PVs that could be connected to heat pumps, and that would have been a very good thing for residents. And the last thing that we looked at, we prepared very easy to read recommendations for residents to avoid any type of performance gap issues, explaining what the heat pumps are, how are they working, how are the other part of the new building features working. So make sure that people fully understand what the project is about, what the new building features are about, and how to best use the properties to them being comfortable and cheap to run, basically. And I think that's me. Thanks very much.
Thank you very much, Barbara, for the very informative and insightful talk about the retrofit heat pumps. So our next speaker is Craig Dolan. He's a product manager of Renewable Systems UK at Vaillant. So for the rest of speakers, yes, please keep to the time, 15 minutes. Thank you very much. So now, Craig, the floor is yours.
Okay, I'll do my absolute best to stick to time.
Thank you. Yeah.
Feel free to interrupt. Okay, so hi, my name's Craig Dolan. I'm the product manager for heat pumps and renewable systems for Vaillant Group. I was also just elected to the vice chair of the HPA as well. So I'm actually going to reinforce the message of Barbara. Fabric first is definitely the way to go. And I've noticed a couple of questions in the chat about ground source heat pumps being more or less efficient than air source heat pumps. Broadly speaking, ground source heat pumps are more efficient because the source temperature that you're getting the heat from is more consistent. You also have the option of passive cooling in the winter, depending on the system design. But it depends on what the property type is. And, if we were going to do a boiler equivalent, installing a ground source heat pump is equivalent of paying for the boiler and the gas main. So sometimes it can be capex prohibitive. But yeah, broadly speaking, ground source more efficient, but air source is definitely looking like the mass market use case. And we have to remember, we need to stop burning stuff. So we don't want to get into an argument of that heat pump versus that heat pump. We need to get off fossil fuels. So looking at Vaillant. So Vaillant, we produce gas products mainly. We've been moving to heat pumps. We've actually had a heat pump in the market since 2008. So we've been building up our knowledge and our skill set and all of that. But if we look at the supply chain of Scottish and UK homes, that supply chain has been built up over years on high temperature systems and fossil fuel based systems. Vaillant Vaillant Group were the first people to produce the condensing boiler. We were first to bring combi boilers to the UK. We were the first manufacturer of gas products in the UK to move away from non-condensing boilers to fully condensing. And we are the first traditional heating manufacturer to start producing heat pumps, and our production lines currently going in and will be active from August. It has become more prevalent now with the energy situation that we've got tomorrow is going to be a very painful day for a lot of people with the energy price increase. It is now becoming a matter of energy security, and to reinforce the message of Barbara, we need to take a fabric first approach. It is all about the system design. We need to reduce our heat losses. We need to reduce heating waste, and we need to build the skill sets across the total value chain for that. And, you know, as a leading manufacturer, we are well involved in that from the start. So, you know, installers, supply chain, wholesalers, manufacturing, consumer awareness, consumer education, it needs to be done across the whole supply chain. So relearning and remembering the skills of the past, you know, poor performance or poor preparation equals poor performance. You can add the other two P's in there if you like. You know, this is something that I say quite regularly in our meetings. Great news, everybody, the heating industry is in the spotlight. We are going to be leading the charge in fighting climate change, reducing emissions and lowering running costs. But also, bad news, everybody, the heating industry is in the spotlight. That will do is no longer acceptable. We really need to step up our game. One of my colleagues kindly pointed out that you can get away with drop kicking a combi boiler onto the wall and the heating system will work. And that attitude is not going to work moving forward. You know, we need to take a downstream approach, looking at the heating system, making sure that heating system is designed to the best of its ability, and then picking the right heating appliance for that system. Basic heat loss calculations need to be done. There's a huge training element that we need to do. We really need to push skills out of academic circles and out of manufacturing circles and onto the front line. So, you know, us and other manufacturers, and I know Bean's been involved as well, we've been supporting the low temperature heating and hot water system course. It's been designed by the Chartered Institute of Plumbing Engineers and Heating Engineers, and we're going to be rolling that out to our installation training centres, one of which is in the Euro Centre in the Belt, and we are looking for further education practices to help push that qualification out. We are going to be doing a heat pump qualification, so the LCL Logic course, so that's a level 3 installation and maintenance of heat pump systems. So really taking the plumbing base that we have and upskilling that to heating engineers. So we're really focused on that. And like I've mentioned, and like Barbara mentioned, actually, I'm really pleased that she presented and I get to reinforce all of her points. You design for success. You make sure that you have done everything that is reasonably practicable to reduce the heat loss and the heat waste of the property. And then you design that heating system to run at lower flow temperatures. Typically, heating systems were designed at an 80-degree peak flow with a 60-degree return, meaning that the mean water temperature was 70 degrees going through your radiators. When we moved to condensing products, that should have dropped to 70 degrees with a 50-degree return. Arguable whether that has happened in all cases or not. And then as we move to the future build standard, which is coming in 2025, we're looking at a peak flow temperature of 55 degrees. So that means radiators and piping need to be sized correctly in order to make sure that the house and the home stays warm and comfortable at those lower flow temperatures, and making sure that the heating system is working as efficiently as possible to reduce the running costs. And, you know, if you lower the flow temperatures required in your heating system, you will automatically get an efficiency increase. So it doesn't matter about the heat source, but, you know, we really need to get off of fossil fuels. And like Barbara said, handing over to the customer is becoming more and more important. How do the controls work? What is weather compensation? You know, one of the stories that I like to tell is we had a lady with a heat pump that was complaining of high running costs. We couldn't understand why running cost was so high. We went round to do a visit. Fortunately, we went on washing day, and in order to get her radiators toasty and hot to dry her washing, she put her room thermostat in the fridge. So the heating system thought it was 4 degrees inside the house. So it was absolutely working as hard as it possibly can because she needed to dry her towels. So, you know, there's things, human elements that we need to make sure that we build into what is a heating system. You know, when you're considering a heat pump installation and it's an air source heat pump, you need to consider the placement of the outdoor unit, you know, fitting it within the property, discussing the options with the homeowner, you know, making sure you consider the points for the condensation to run off, the clearances to ensure the airflow, reminding the customer that it's not a place to stack their garden furniture in the winter when they don't need it. You can use covers to cover the heat pump if you do wish, because you don't want to look at it. They are available. One of the key questions that we get asked quite a lot is, oh yeah, but it's going to be really noisy. Some of the older heat pumps were louder than they are now, but just to give you some sort of context, the new range of Vaillant heat pumps are as quiet as a boiler flue. And I have checked, and I do check regularly, but we have never had a complaint about a noisy boiler flue. So, you know, all of the manufacturers in the UK are investing heavily in R&D to make sure that we get as much efficiency and comfort, and they are as quiet as possible in their homes, because we want people to buy our units and not feel that they're forced to have them. So selecting the correct system for your home, you know, this is important. We really need to get out there the understanding of heating system design, and getting that design skill level up, and then making sure that what has been designed is actually being installed. You know, making sure that the heating system is like invisibly brilliant. You know, British Gas have built a whole business model about the fear of your boiler breaking down, because when your heating isn't, you know, 3 times that people care about their heating system: 1, when it's not working; 2, when it's when you've got a large bill; and 3, when it's not working. So we need to make sure, and yeah, I know I said 1 and 3 the same. It's supposed to be a joke. It's hard to do it online. You can't see anybody. But it's about making sure that the heating system just works. We don't want it to take up any headspace. We don't want it to be giving out any emissions. We just want people to be warm and comfortable. And as I mentioned in the chat, there's a huge opportunity once we get to a critical mass that heat pumps and EVs become smart energy appliances. So, you know, with a fossil fuel, it's always going to be burning something and that's the end of it. But if you've got something connected to the grid, it's not beyond the realms of possibility that can become a smart asset to help balance the grid moving forward, and to use energy at its cheapest and not use it when it's at its most expensive. And there isn't any one size fits all. There's, you know, the heating appliance, the cylinder sizing, you know, the energy storage like Sunamp with David, that's going to speak after me, that we've done systems with, you know, linking with PV, so you can do self-consumption, so you can boost your hot water temperature, or, you know, effectively do free cooling in the summer. There's also the ability for harder to heat homes, or rooms that really need that extra power in deepest, darkest January, for hybrids. I've had a hybrid on my house for the last 7 years. The heat pump does 90% of my heating, and the boiler is linked to a combi boiler that does the hot water, and it's effectively a turbo. So it's tariff controlled. I put in how much I pay for my electricity and how much I pay for my gas. The heating system works out which is the cheapest, and more often than not, it's the heat pump. And it also means that the heat pump never drops an SPF, COP or SCOP of 3, because if it goes below that point, then it's cheaper to run the gas boiler. So, you know, there's a lot of work to do. The heating appliances is broadly speaking the easy bit. It's getting the skill level up and getting the supply chain ready for the difference that is going to come. And with the energy crisis that's gone on and the Ukraine situation, that is only going to accelerate. So, heat pumps will become a more of a core technology in the next 3 to 5 years rather than 5 to 10 years. It is going to switch quicker, and we need to be prepared across the whole of the supply chain to make sure that happens. And that's me. Hopefully, I was on time. Stunned silence. Anybody there?
Sorry. Thank you very much, Craig, for your very informative discussion on the heat pumps and the installations. So our next speaker is David Wright. He's a national sales manager of Sunamp. Sunamp is an expert company on heat storage and heat batteries. So David will talk about the heat storage and technologies and the applications. David, the floor is yours.
Yes, thank you, Zubin, and thank you, Craig. Just give us a second. For some reason, the slides have disappeared from the screen, or from my screen. Can you see my slides at all?
I can see your slide.
You're on slide 3. Yeah, that's slide 1.
Yeah. Right. Okay. For some reason, I can't see the slides, so hopefully this will still work. If I start going ahead, please just somebody butt in and let me know. So, yeah. There we go. So, well, hello everybody. As Zubin introduced me there, I'm David Wright, the National Sales Manager for Sunamp. Sunamp is a company founded in 2006, and our mission is to basically help with lowering carbon emissions from heating and cooling by optimizing renewables with our thermal storage technologies. Now, as it was mentioned earlier on, very much Zubin was right. It's a case of heat does account for 46% of the world's energy consumption, and as things moving on, we're getting used to seeing electrical batteries. But here's the thing: why don't we start storing heat, which accounts for far more energy? And it's if we can store the heat, and store energy that's generated by wind and solar, and as is intermittent energy supplies. It makes it far better for the environment, far better for us, certainly in our pockets. So when we are designing sort of products these days, we have to consider lots of things. We need thermal batteries to work with heat pumps, obviously is the main driver going forward. Be able to work with solar PV, but also grid still. A lot of houses will be forced to use grid electricity, to heat their heating and their hot water. So we have to make sure we can get as efficient product as possible to help these people. Same with district heat networks. We're using waste heat as well, from the mechanical ventilation. And what we've done with our thermal batteries is we can utilize all that to help drive down costs in the home, but also carbon emissions. So it is a case of today is how do we meet the customer's needs? Now, you'll have all seen, I think, as you say, Barbara touched on it earlier, you go back to 1970s, 1980s, nearly every house had a system like this, tanks in the attic, hot water cylinders, oversized radiators, pretty much an inefficient boiler, albeit efficient at the time. And it worked away, but fuel was, energy was cheap, so people were happy with that. We then moved on to the rise of the combi boiler, small thing. And as Craig mentioned, plumbers got very much used to drop kicking these onto the wall, and pretty much 99% of the time they would always work. People would be happy. What this allowed people to do was obviously make smaller radiators, smaller pipework, but also redesign their homes, which meant where the cupboard was for their hot water cylinder basically was removed, and bathrooms would be increased in size, bedrooms might be increased in size, just disappeared out the person's home. So what we need to go back to now to heat pumps, and you can see here This is just a model with an internal unit that Craig was mentioning, the sort of hybrid thing here. We now need to find a space for our for hot water production, you know, because the air source heat pump can't do it. So it is a case of we've came up with a solution, and that solution is driven by a product that sits inside of ours called Plentigrade, which is a phase change material. You know, now phase change materials, they're not new. They're certainly new in the heating world, but phase change materials were first, you know, discovered, if you like, way back 260 years ago by a person, Joseph Black, who was the professor of medicine at Edinburgh University. You know, and he discovered latent heat. You know, very simply, as you all know, you know, you have a block of ice, you start to heat it up, it will turn to water. But at 0 degrees, once it reaches 0 degrees, you can keep putting heat in, but the temperature remains the same, i.e. latent heat. Now, very much, as you say, he also discovered carbon dioxide, which is why we're all here and we're all what we're now trying to reduce. Moving on, there's then a woman, Maria Telkis, in the 1950s, 60s. She created the first heat battery and the first solar powered home. Now, the downside of it was worked very well for the first 2 years, but then after that, it didn't. The actual phase change material started to break up, and it basically, the system became so inefficient, it was basically scrapped. And this is where the collaboration between academia and business absolutely works. Through our founders, Andrew Bissell's sort of connections at the University of Edinburgh, we started to work on a project to develop a phase change material. And a PhD student, David Oliver, at the time came up with the solution, which we've now called Plentigrade 58. And basically we have now perfected this formula where we can now have 40,000 cycles, which is equivalent of 50 years of the phase change material going from solid to liquid and back again, which is certainly far better than the original ones, which only lasted 2 years. Now, when we talk about phase change, you'll have all seen these wee hand warmers, and you know, quite common these days. And our products work exactly the same way. While it's a liquid, the energy is stored within it, and then as soon as you start the reaction, the liquid starts to release the latent heat, which in our case heats the primary water as it goes through the pipes into the tap. Now, one big thing about it, just to put people's minds at ease, we have been independently tested by the ZEE Bayern Institute over in Germany, and we are the only company in the world to have a product that is A-rated, and they don't go any higher. We've tested to 40,000 cycles, as I mentioned, but it's a case of it's a nice point for us being here in Scotland, a small Scottish company, to be the only company in the world that can do this. So sorry, this is a wee part mentioned. This is what we do here, similar to the ice that I mentioned earlier. When you're heating up water or you're heating up our phase change material, once you get to 56 degrees, you'll notice our temperature stays exactly the same, and we just start storing energy in the same volume for liquid, where the water carries on. You know, as you get more energy in, the temperature increases, but with us it stops until it gets to about 58 degrees, and then again it starts to rise again with the temperature, with the amount of energy you're putting in. Now, what does this allow us to do? It basically allows us to do this. So where you would have a big cylinder in your house, this one here is a simple dimension of a 300 litre cylinder, which will be by far the biggest cylinder you'll ever put in a property. We have now got it down to just above a metre high, you know, 365 wide and 575 deep. So it gives you far more options to, you know, when you are siting a cylinder, or in our case a hot water battery, into a property that has very, very few cupboards, you know, or cupboard space. You know, oh, jump 2 slides. So in here it is in real life. You can see here, this is in our customer experience room. We have a mega flow unvented cylinder right next door to a cupboard, and you can see the absolute difference in physical size there between the two. But because we're doing this size reduction, if you want to, here's a unit here just underneath the sink, and that size of unit would give you 150 litres of water, you know, which would be more than ample enough for a standard house with one bedroom, one ensuite, one bathroom, one ensuite. And so you can see there, it just takes half a cupboard space almost, you know, so very, very flexible in where you're siting it, you know. But to make this work, it is very much, you know, it is a case of it's comparable in price to hot water tanks, but more importantly, because of what we do in it, it's a lower total cost of ownership. But just as importantly, it's cuboid, you know, which means it can sit in tiny wee spaces, or stackable if you so wish, if you need that wee extra bit of hot water. And what we've also done is very, very low heat losses. You know, there's no point creating heat if you're just going to throw it into the air. So as you can see here, this is a 300 litre cylinder, and it's, you know, its heat loss is 35 watts, making it an A+ rated hot water. So most cylinders out in the market just now, most are C's. There's a couple of B's, and I think there's one other one that's an A, but not throughout the full range. You know, it's usually the smaller ones, where this is the biggest domestic cylinder you'd probably ever need, and it's still an A+. And here are some of the advantages of having the heat batteries in there. As I mentioned, 4 times smaller than cylinders. You can use it with any sort of renewable heat source, whether that's heat pumps, solar PV, and if you so wish, you can even use it, if you have a combi boiler, you could even use a heat battery as a preheat for the combi boiler, you know, just linking it to the PV, which would still give you 70% of your hot water for the year, and further reducing your, you know, your carbon emissions and your costs. You know, if using air source heat pumps and everything else isn't viable, you can still help, you know, the homeowner in the meantime. You know, it is mains pressure, so your customers are, if they're used to that, you know, through combi boilers, they'll still get it with ours, you know. But just as importantly, unlike a cylinder, it's, as we're not storing water, we don't have a lot of the safety valves that cylinders have, so there's no need for servicing. So it is a case of, you can put it in the corner, box it in to a certain degree, and just forget about it, which is, I like Craig's analogy, you only remember things when they don't work, and that's very true. Same with a cylinder. But as there's, you know, no moving parts in our product, very little ever goes wrong with it. So a couple of little case studies of what we've done with being able to use these heat batteries and find space. You can see here, this is the electrification of heat project we did in partnership with Vaillant, where we used the Vaillant heat pump. We've used the My Energy NDV PV on the roof, and if it wasn't for the fact that we had a small battery, there was no way that install could have went ahead. The fact is, you can see the amount of sort of pipe work that was required for this particular system, and our heat battery just sitting at the side there. So it is very much enabling homeowners to use the technology that's out there to benefit themselves and use heat pumps. We can also, I've seen in the chat, there's talk about ground source heat pumps. We've also been involved with a decarbonisation of high-rise blocks. Now, this was in Sunderland with the Gen 2 group, where we changed the decarbonised 364 flats, you know, using a shared ground roof array. And again, it was a case of, used to a combi boiler, you can see the amount of space they've actually got in here. And from this picture, yeah, we've got an example, a wee Kenza shoebox heat pump, and another cupboard in the background there is our heat battery, and with all the other electrical, heating system controls, you know. But if it was a combination of these two technologies being used together, it made this project viable. And very much just as important, this was all done without having to decant anybody from the property, you know. So we can actually do these, you know, upgrades without having to have void properties. So it's always something to bear in mind. And you can see there, you know, this project, it's saving 420 tons of CO2 per year. So very, very much worth doing. And as the fact is that, you know, the ground source heat pumps are very cheap, and the heating bills have actually come down for the tenants in these properties. So a very, very worthwhile exercise. So that's me wrapping up. I look forward to your questions at the end.
Thank you very much, David, and very good timing. Thank you for the very informative talk about heat batteries and the applications. Thank you. And so our next speaker is Professor Ken Gibb. So he's my colleague and a professor in housing economics at the University of Glasgow. Ken will give us a talk about the retrofitting of heat pumps from the user's perspective. Ken, the floor is yours.
Thank you. I hope you can see the slides okay?
Yes, I can see.
Okay, brilliant. Yeah, so I am going to talk about some of the work that we've been involved in and how it relates to this kind of perspective of the user, and a bit more widely from that. So I hope you'll all tolerate an incursion from a social scientist, where the pace will be a little bit different to what we've just been hearing. So a little bit of background. I work and I direct the Collaborative Centre for Housing Evidence, which is about combining research and evidence to impart knowledge exchange, which can hopefully lead to a positive progressive impact and influence on policy and practice on housing across the UK. We draw on international evidence, and we have co-investigators from 13 institutions across the UK. And as you heard from Barbara, we were involved in the tenement Enefit retrofit project at Midway Road. So we led the Scottish Funding Council's evaluation of that project, and I really reiterate everything Barbara said. And I guess would make a couple of points there. One is that yeah, I think we've all been struck by the soundness of the idea of fabric first, of really getting airtight insulation combined with ventilation to reduce energy demand, and it's in that context that then the renewables are applied. Secondly, as Zebin knows only too well, we're working with him on the EPSRC Fashion project, which is about developing a more efficient air source heat pump for residential purposes. We're doing the social science contribution to that, which is about the barriers and enablers to residential heat pump take up, and also to ask the question, really, why is it that penetration of the market is so much deeper in other continental European countries? What do we need to do to change that? And the third bit of background from research is that I last year was on the advisory group of the Grant Thornton scoping project, which was carried out for the Glasgow City region to look at a mass retrofit programme as essentially a COVID economic recovery programme, which would have the effect of greening jobs, of creating supply capacity, and making a really massive impact on decarbonisation. So that was a really interesting project because it really brought home the scale of the challenge, the nature of the types of collaborations that have to take place, the role of the public sector, the role of the private sector, the role of skills and training, etc. Really an interesting piece of work. So I want to talk a little bit about what we're doing in the fashion project, because I think it's directly relevant to what I've been asked to talk about. And we kind of see the issue of overcoming what you might call the non-technical or the economic and social barriers to greater uptake of heat pumps as being a threefold set of issues, really. One is what I would call industrial organisation, which is really the industrial economics of the supply side in the broader sense. How can it be incentivised? How can it be supported to be much more heavily involved in renewables at scale? Because it's only when it's at scale, clearly, there's going to be the economies of scale that drive down costs. Secondly, on the demand side, there's kind of these behavioural economic questions. How can we incentivise and encourage consumers, households, and individuals to invest in something that currently they don't seem to want to do? What are the mechanisms that might be used there? What nudges or possible incentive structures could be aligned? And thirdly, more systemically, when we think of these big technological changes impacting on society. There are models going back to the 50s of what we call a socio-technical approach, which thinks about where are the leverage points that can really make a change and really capture the potential benefits, and in particular, what's the most effective role of the state in encouraging and pushing that thing forward. So they're the kinds of frameworks that we're going to use in the project. I'll just say a little bit more about each of them. The industrial economics stuff, I did some work in the 1990s about what we call a structure, conduct, performance framework to look at the house building industry in Scotland. And that's about thinking about market share, thinking about how competitive the sector is, how profitable it is, what its practices are, to what degree is it innovative or not, and why, and what the challenges facing the sector. And I think we need to really understand not just construction, but obviously the installation industry, the maintenance industries that may be involved in this in a different way. So we're going to try and understand that in the work. On the behavioural economics side, there's really 2 or 3 issues, I guess. These are investments which have a long payback period, so we need to think about it in a longer term time frame. So behavioural economists got very interested in what they call hyperbolic discounting, which is essentially where, I mean, in a crude sense, people's time preferences are much more focused towards the present and the near future, rather than the benefits that accrue in the longer term, which is kind of different from what neoclassical economic theory says. We also recognize that this body of work is built up, shows a lot of biases in people's decision-making relative to what would be the standard kind of expected utility, rational choice kind of thinking. And that all leads to this kind of nudging choice architecture work, which is what the Behavioural Insights unit in Whitehall are associated with, and many of the Whatworks centres as well. How can you redesign elements of policies and practices to achieve more desirable social outcomes, which are in the interests of the individual, arguably, in some cases, but are certainly in the interests of society? So one of the things we'll talk about in a minute is a couple of the kind of financial or subsidy-oriented ideas which might be of use for encouraging people to go down a renewables route and a heat pump route. I'll be a bit more brief with the next rather complex slide, because I don't really understand it all, which is a kind of summary overview of the socio-technical approach to new carbon carbon reduction technologies. And the idea is it's like a systems thinking approach where we understand that the goals of what is going on, but also alongside that the technological changes and how they impact with society and create leverage points and places in which economic innovation can actually be very profitable, I suppose, but also achieve the goals that society has. So we think this is a useful way for understanding this, not least because we're talking about a major transformation in the way that the energy economy works. And also in most of the case studies of using this kind of approach going back 50 years or more, a lot of the focus, as I say, is on the appropriate intervention by the state to help early adapters, to help develop scale, and perhaps to invest in skills and training and those sorts of things too. So we think this will be an important way of making sense of this new energy economy and how we can help the heat pump sector grow. So I've been much quicker than I anticipated being, but this is my last slide. I just wanted to make a few general reflections, I guess. As I say, I think the key thing here is what are the social, economic, institutional factors that allow the energy economy to get to a critical mass with things like heat pumps, the things that we want to see mass produced, standardized, highly efficient. Ranged against that, I think there's what you might call a kind of direct and indirect conservatism, a resistance to change. And the direct conservatism in this context is our consumers, who, for whatever reasons, are unwilling to change the kinds of systems they have They like the systems they've got. They don't like change. They're worried about the costs. They're worried about the uncertainty. And one of the things that I hear a lot from the social housing sector is that as often the guinea pigs of energy policy reform through things like the ISH1, ISH2 programs in Scotland, as have happened recently, there's a slight worry that what's today's energy efficiency program may be deemed to be very inefficient in 5 or 6 years' time, and that changes have to follow. And that's obviously not a very good place to be in if you're making big capital investments and really shifting your asset management program in a certain direction. So you can understand that kind of conservatism. And clearly there are some straightforward economic points. The high capital costs we've heard, it's an unenviable trade-off between high capital costs and lower running costs, because if people are fronting up the capital costs in the first place, that's a challenge. And there may be clever financial ways that we can help with that and benefit from the lower running costs in the future. But I've also been thinking about the indirect effects, which relate to actually the way industries like the house building industry often perceive their customers. And if they think their customers are conservative, they're going to be conservative. And that's a real challenge, I think. And that's certainly in a broader sense about house building viewed as one of the challenges of mass volume house building and such like. And it's clearly the case that there are developers who have either been incentivized or are early adapters and who are doing low energy new build housing. So it's not in any sense that it's impossible or it's unlikely, but I think we do need to recognize that there's a conservatism which needs to be challenged as effectively as possible. So there's a couple of quite interesting, well, more than a couple, there's lots of interesting research out there about climate change, net zero and housing. The CCC Committee Climate Change Report 2019 is quite broad and quite high level in what it says about retrofit. But actually what I've always found much more on point is the Green Finance Institute work. So they did a report in 2020, which is concerned with scaling up financial innovation. And the nice thing about their research is that they sort of dive deep into the housing system. They look at what are the challenges in the home ownership sector, what are the challenges in the private rented sector, etc. And I think they create a series of ideas, which I think are interesting, but they are specifically targeted at the issues that arise. So I'll give you a couple of examples of what they talk about. They're interested in what they call green equity release, which is to encourage over 55-year-olds to fund retrofit work through equity release products. And in a similar vein, they're also interested in what they call help to green, which is a form of shared equity. So what that requires is to essentially take a loan from government or a public agency to get either to pay for all or most of your retrofit costs, your renewable investment, and then that becomes a charge on the property. So when you sell the property, basically you pay the state back. So that's to me is quite interesting, not just because it's a pain later, and that the government can almost be an investor in this process, because if it's an equity share, then their equity might go up, whereas it's an equity loan, it doesn't necessarily go up, but they get paid back. But more to the point, the money's potentially recyclable. You can use it again. So that's actually quite good value for money in a world where we seem to spend lots of money with not a lot of thought about it's the value for money that sits within it. So I think these are quite interesting ways of trying to provide what's probably required as a menu of incentives and subsidies and financial products to make some of that upfront capital cost pain less severe. So I'll stop at that point. I don't have any great answers, but I do think there's a wide range of things that could certainly be discussed a lot more, and it's now increasingly urgent that they are. Thanks.
Thank you very much, Ken, for your very insightful presentation about the heat pump retrofitting from the user's perspective. So we will leave the question at the end. So our next speaker is is Mr. Vaillant. He's the director of the Growth and the External Affairs at the Heat Pump Federation. So, Vin, when you're ready, the floor is yours.
Lovely, thank you very much. I hope everyone can see the slides. I'm very lazily having them driven centrally. So you can pop through straight to the first slide, please, Anne-Marie.
Yeah. Yeah, the slides are good. Yeah.
Yeah, do you want to move on to the next slide? Perfect. So look, I'm going to try and dance through this a bit to leave some time for questions, because I think we're running a little bit behind time, and I'm certainly very keen to hear what the audience has to say. So look, the view from the Heat Pump Federation. So I've been given 3 topics. What's held us back? What is the consumer? How does the consumer navigate the advice minefield? And what policy changes are needed? And I've subtitled that to get to 600,000 units per annum by 2028, which is the current target. Next slide, please. So first of all, this is a slide I've nicked from another presentation here. Why is electrification carbon efficient? But the important thing to note here, and this is one of the holding back issues, is so this is a screen grab from an app which sits on our website, Carbon Watch. And what it does is it takes real-time data from the grid, shows you what the carbon intensity of the grid is, which is the box on the top right, and then converts that into real-time emissions on primary fuels. So coal at the bottom, oil, gas, resistive heat, and then 2 heat pump efficiencies. And you can see that there's a massive advantage, carbon advantage, even against gas. And this screen grab was taken a while back. The grid was operating pretty well at 110 grams. It was 8 o'clock in the morning, so it must have been quite windy. But to put it into context, the reason why this demonstrates one of the holdback factors is that the black vertical line is where SAP currently reports the grid carbon factor at 519 grams of CO2 per kilowatt hour. And it's been sitting there since 2012, which clearly has failed dismally to reflect the decarbonisation of the grid. We've been asking for a change to this figure since 2014. We're going to get it in the summer. Which is just hideously poor performance by government. Next slide, please. Also, can we afford it? People say, oh, the government can't, country can't afford this decarbonisation malarkey. This is a snapshot taken from government figures. As you can see, it stops at 2018, but the direction of travel is been consistent. GDP, our UK GDP, pretty well matching the rest of G7, but look at the emissions. We got massively reduced emissions compared to the rest of the G7. So absolutely, there is nothing incompatible between decarbonisation and successful economics. Next slide, please. So we've had subsidies. Everyone says, what, you must have been marching on with subsidies. Well, look, non-domestic RHI payments, this info I think was around about the end of last year. This shows you the amount of money in the non-domestic RHI that went to heat pump technology. As you can see, it's less than 2%. So 98% of the money in the domestic RHI went to some form of biofuel. And yet under the low carbon building program, which predated the non-domestic RHI, heat pumps were outselling biomass. So what does that tell you? It tells you there was a massive problem with the way the RHI was set up. It was hugely slated in favour of biomass. And I'm sorry to say that lots of people have now invested in biomass systems, which they're asking us to consider taking out as soon as the subsidies are finished. Next slide, please. Not so bad for domestic. You can see about half the money has gone to heat pumps. So that was largely down to a correction in the tariffs that was made rather sooner in the piece on the domestic side. Next one, please. And just another reflection on exactly the same thing. BISRIA figures for sales. You can see what happened. Heat pumps and biomass roughly in parity. As soon as the RHI applications opened, biomass absolutely took off. People followed the money rather than following the best engineering advice. Next one, please. The further aspect to what's held us back is affordability in operational cost. So capital cost, can you raise the money? But operational cost. Well, these are the breakdowns from Ofgem's website on the fuel bills that we're all paying. Obviously, the price is changing tomorrow, but the proportionality will remain much the same. This just tells you that the polluter doesn't pay. So the environmental and social obligation levies, which are placed on both on all primary fuels, as you can see, the levies applied to gas only 1.86%. The levies applied to electricity 22.92%, and that was originally done to fund offshore wind, to decarbonize offshore wind and solar and things to decarbonize the grid. What the government should have been doing is monitoring the success of that investment. And as the grid hit parity with gas, should have started moving those tariffs across to either fossil fuels or to general taxation, one or the other. But instead, they've allowed the problem to build up, and we've now got this horrific situation where it's cheaper to pollute. We have completely forgotten the concept of the polluter pays. Next one, please. So that's why we've been held back. We've had 519, we've had poor subsidy policy, and we've failed in our taxation strategy. We've encouraged polluting. Customer journey. So domestic consumers, what's the challenge for them? It's huge, actually, I think. So fossil fuels work. We've heard some comments, previously this morning about this. Or do they? We've heard comments about non-condensing boilers, condensing boilers. So in 2005, we mandated for condensing boilers. We completely forgot to mandate that they should operate in condensing mode. There's a significant body of evidence that suggests if all the UK's condensing boiler fleet were operating in condensing mode, we wouldn't be buying any Russian gas at the moment. We wouldn't need to get away from it. We're not buying. We wouldn't need to buy any. Oh, we just flip slides. Resistance to change. We've heard some comments about that, and this is where the social, and I think that academics can really help us here with understanding the social impacts of change and the resistance and fear of change, because that is very real. People, particularly when people are getting conflicting advice. So at the moment, the consumer is being bombarded. Put in a heat pump, wait for hydrogen, do this, do that, put some solar. The tendency is when people are confused is that they do nothing. And so we need to, I think, try and get much, much clearer about the messaging to the consumer. And here we've got to, I think, start breaking the market down a bit. Waiting for hydrogen might be an option for those that are on the gas grid. Hydrogen is never going to be a solution for those that are not on the gas grid. So we need to absolutely start getting the message across to people, in a different way, depending on where they currently are. We have a very low valuation of energy. Until very recently, the last 9 months, energy was considered to be so cheap. People, by and large, were happy to waste it in a very, very profligate way. I absolutely accept there are people in fuel poverty, and there are people that have always found it difficult to meet their energy bills, but many of us, I'm afraid, were happy to continually waste energy. We resisted insulation. We were very slow to insulate our loft space. We're all very bad about what's the word I'm searching for? Draft proofing. So we've been poor. Now that energy is becoming expensive, suddenly it's an issue. Actually, that's no bad thing in the big picture. Capital cost. We've had poor funding policy. Clearly, that's a problem. And operational costs, we've talked about the breakdown on bills. And we've had poor knowledge and understanding. We're not good at getting the message across to consumer. In fact, I don't think we know who the consumers really trust. Do they trust government? Not sure. Do they trust big business? Not sure. Do they trust Amazon or Tesco? Don't know. Evidence suggests they might trust them more than government. Some of the researchers said that what they really like are local champions. So can we get local champions to start promoting these technologies? If someone in your street has a heat pump and talks about it, we've had instances where installers have done a heat pump installation in a village which is off gas, It's been a great success. They've then rented the village hall, invited everyone in, given a presentation, and away, another 8 to 10 projects in that village. So I think local champions are a big piece. On the positive side, we've got environmental attitudes. Sir David Attenborough, biggest rock star at Glastonbury 2 or 3 years ago. Greta, like her or not, she has made an impact, and that has increased the intergenerational pressure. We've got to remember that the house buyers of the future are the current students, and they are absolutely all over this stuff. I presented to a group of sixth formers a few weeks ago. They were all over this. It was brilliant. Regulations are coming. We've got the consultations on the off-gas, removal of fuels, fossil fuels from off-gas. And we've got this question about affordability and fairness, some of which has been already touched on. Next slide, please. So what do we need to do to deliver 600,000? And I'm really sorry I'm galloping through this, but I do want to hear, I think we all want to hear what some of the participants, what some of the delegates will have to say. So we need to build consumer confidence. And for me, that comes from robust consumer protection. We need to give them an affordability package. I actually don't like subsidies and grants. They always throttle investment because they always have a cliff edge. And that investment throttle, I think, applies to consumers as well as to industry. So I think the affordability package needs to come from a loan scheme. Our previous speaker was talking exactly about this, PACE lending attached to the building, very ultra low interest rates. And if we're reducing the price of electricity, it means the operational cost falls, the whole thing becomes self-perpetuating. We've got legislation coming, Future Home Standard, which is going to start to transform the new build market. And as I said, we've got the legislation off gas. The Scottish experience says, loans, fantastic. Deployment has increased hugely with a loan scheme. I know it's zero rate, and I don't think that that's affordable on an ongoing national basis, but it does show there's no resistance to loans. Next one, please. So, we're able to pay customers fund decarbonisation. Well, actually, I don't like able to pay as a term because it applies to just about everybody who isn't in fuel poverty, and not all of us have got the money down the back of the sofa. What I do see, though, when I talk to community groups, which I'm doing about once a week at the moment, is we have a number of people who I would term willing to contribute. So they want to do this, but they want help, which is where the loan terms comes in. Everyone loves a handout, but actually we've got to be realistic. There is not a lot of money around after the COVID piece. We've got to be more realistic. Private investment in decarbonisation, yes, good for your home, but actually it's a public good. So there's a societal benefit which does justify government coming up with an affordability package that is somehow spread much more evenly. Next slide, please. And in terms of social housing, public sector, these can be the big drivers because no one's going to pay for this apart from the state. So we can absolutely crack on with funding social housing. We heard yesterday a really interesting piece from the Energy Systems Catapult, an event I was at yesterday, about how improving people's heating reduced their burden on the NHS. A fantastic pilot scheme that was running in the Midlands, absolutely brilliant, really moving presentation actually. So there is payback in all sorts of other ways across society by improving people's living conditions and their housing. Public sector buildings, I think we can do a lot with the public sector decarbonisation scheme that we're currently not doing. The last thing really I want to centre on is this flexibility value. We heard a great piece about Sunamp, the history, the technology. Flexibility from heat pumps is going to be really, really important. Next slide, please. Okay, this is it. Flexibility, Imperial College, Carbon Trust put a value on flexibility, which for us is load shifting. So running heat pumps when electricity is A, cheaper, B, lower carbon. That value, £16.7 billion per annum by 2050. We have to access that. That's how we're going to pay for all this sort of stuff. The last one, please. Last slide. this is where we need to get back to. I live in Wiltshire, so this is one of my favourite shots. We have to get back to recognition that our primary energy source is the sun. So Stone Age didn't end because we ran out of stones. And it doesn't matter whether it's ground source, air source, solar, wind, tidal, biomass, it's all driven by the sun. That's where we've got to get back to. Thank you very much indeed.
Thank you very much, Dean. A very interesting presentation, a lot of information. Thank you very much, and thanks to all speakers. So we got about 10 minutes to 12 minutes left. So I will put one question to each speaker, and if there are more questions, and then please get in touch with Anne-Marie, and we can send to the presenters to give you some answers. Okay, so the first question, and I will put this to Barbara. So there's some questions about the comment and about the fabric first. I think this has been echoed by 2 or 3 other speakers, and they all recognize this fabric first is very important to ensure the transition from the gas boiler to heat pumps. So you mentioned in the presentation, in your talk, so there's some kind of schemes to support it. So what do you think is any barrier to holding back this scale up of the fabric first or the insulation improvement? Can you comment on that, Barbara?
I think Barbara might have had to have left.
Oh, yeah.
So I don't know whether she has. I mean, she's still online, but she did say she might have to leave.
Yeah. So, do you have any comments on that?
Oh, sorry, I wasn't listening to the question. Look, fabric first. Yes, absolutely. Fabric is really, really critically important. The 2 points I would make is we mustn't confuse that potential there, that fabric first approach. We mustn't confuse that with a concept that says that you can't put a heat pump into a leaky building, because you can. We've just done Bath Abbey. You know, a leakier building, it's hard to imagine. That is now heated with water source heat pumps. So that's my first basic point. So yes, absolutely, insulate, draft proof, good. Deep retrofit, I think, absolutely is a good fit in certain circumstances, but we've got to be mindful of the capital cost of deep retrofit, which can be very high. And you have to ask yourself, how long do you have to then run your reduced energy demand in order to pay for that capital cost? And it really depends on whether we're primarily interested in reducing costs for the occupants of the home or reducing carbon. Because if it's all about carbon, we can probably do it more cheaply than deep retrofit. If it's about cost, and in social housing it is about cost, then deep retrofit obviously is the thing of beauty.
Yeah, thank you very much. Then another question is about the heat pumps. I like to put this question to Craig. Yeah, so you mentioned in your presentations there's a kind of demand of temperatures for the heat supply, because the current houses, the old houses, particularly for retrofitting applications, the radiators, the heat emitters are designed for high temperatures. And when we switch transit to heat pumps, so there's likely a mismatch of the temperatures for the supply from heat pumps and the radiators we have in all the houses. So do you have any comments on that and how this can be addressed?
So yes, the radiators would have gone in and they would have been sized for a higher flow temperature. But if you take a 1970, well, if you take pretty much any house in the UK, some form of fabric improvement would have happened by now. Whether that's the windows have been replaced with more modern double glazing, whether the cavity wall's been done, whether the loft has been insulated. So some of the on the front door being replaced, back door, all of that kind of stuff, some of the fabric improvement would have been done. So that radiator that is in that room may be the right size for a lower flow temperature. I could see Isaac nodding his head a little bit, but the point is, we don't know because nobody has done an assessment of it since it was installed. And if we're brutally honest with ourselves, you know, big flipping window, big flipping radiator was the general rule. So, you know, if you look at go in some houses, the radiator is about a third of the size of the window, and it's got nothing to do with anything else. So the problem that we've got is we don't know what size the radiators are, and we don't know if they're the right size. But if you are replacing a traditional heating system, you don't have to, and nobody ever checks. Whereas if you are putting in a heat pump, you have to check. And we need to get to a point where if you are replacing any heat source in any property, you should check the heating system to make sure that it is running at its most efficient and optimized, you know, balancing water quality, making sure the radiators are correctly sized. It could be that you don't need to replace any of the radiators. It could be that you need to replace half the radiators. It might be that you only need to replace one radiator. We just don't know because nobody's collected the data.
Yeah, thanks a lot, Craig. So there's a demand for research in this area. So I'm pretty sure there are quite a few academics here. So I hope there are opportunities for discussion and to explore the kind of research opportunities in this area. Thanks a lot, Craig. And so David, I have a question, one question for you. So in the chat box, there are a few people, participants comment on that the heat pumps, the transition to heat pumps will basically cause the spikes of power demand. And so your presentation, you talked a lot about the heat storage. Can you comment on that, how the heat storage can make a contribution to address the kind of power demand spikes issue?
Yeah, I think absolutely, Zubin. I think Bean made a very good point. Load shifting is a very important way of reducing these spikes going forward. And where we are just now as a company with thermal storage batteries is the ones I showed today are for residential properties, and they can be charged up any time of day or night, whether it's for space heating or whether it's for hot water. We have that technology, so we can move away from peak time demands and load shift to heat the batteries any time of the day or night, whenever electricity is at its cheapest, and then utilize that heat, you know, when required. But as I did see in the comment as well, we can go up to like 2 megawatt, you know, thermal storage, you know, so it's very much a case of even if there is a, you know, district heat network that wants to load shift, we can facilitate that. The technology is now there to do that, you know. And then when you compare that to electrical batteries, it's at a fraction of the cost. You know, we can store that heat.
Yeah, thank you very much. I think this is a very good strategy, and also being highlighted in his presentation about the value of the flexibility is huge. It's really huge. So the storage, the heat storage will definitely make a good contribution to the flexibility for the whole infrastructure.
Yeah, you're absolutely right, because it's you know, studies have shown that if you load shift your hot water demand to 2 o'clock in the morning, nobody actually notices. You know, you don't have to do it at 6:30 in the morning when you get up. You know, do it 4 hours before. It makes no difference to the person's use of the system.
Yeah. Thank you very much. And I think Professor Ken has another meeting, so he left. So I think the next question is posed for all of you. So we have wonderful technologies from heat pumps to you know, house insulation improvement, to heat storage, and to your solar PV panel or solar thermal panel. So the question is, we currently have a lot of people living in fuel poverty. So once we transit, or during the process to transit to these wonderful technologies for heat decarbonization, how are we going to address the fuel poverty? And I don't know which speaker I should pose this question to. So I put to all of you. So who'd like to give a comment first? Yeah, please. Yes.
I'm happy to kick off on this one. One of the things that depresses me is that we kick those who are least capable of defending themselves when they're down. The concept of prepay meters, the premium price they attract, and the fact that you can't access time of use tariffs and things through them is just a disgrace. You know, I posed this question to the Energy Networks Association, you know, gathering of, you know, all the big electrical players in the country. Actually, they couldn't tell me. There was no one around the table who could tell me what the situation really was, the regulatory situation around prepay meters and access to lower tariffs, time of use tariffs, and what have you. You know, so we got a lot to do, and we really have in social housing. But there is no doubt in my mind that actually this is part of the fair transition. And I think that if we're going to carry the population along with us, they want it to be seen to be fair. And so I think that getting taxpayer to fund social housing, you know, and look seriously for Treasury to seriously value how much improvement does this make to the NHS budget. You know, if they value that fully, properly, and set that against the cost of doing the job.
Yeah, thanks.
Yeah, I'll come in as well. I just wanted to add that if we knew the answer to that question, I would like to think that we'd already be doing it. It is really hard. The presentation that Bean mentioned about the link between cold homes and respiratory disease and heart attacks, there is a very, very, very clear link there, and it isn't valued enough. And, you know, we have to remember that heating is on that bottom rung of Maslow's hierarchy of needs. So if people are cold and uncomfortable, and, you know, that has a direct link to feeling unsafe, then the whole rest of their life cracks. And I don't think that that social link has been made firmly enough in people's minds, and everybody just sees it as a cost for a cube of energy. We need to do more to switch that. And, you know, and like I think most of the speakers today, it's about reducing waste. And once we start reducing heat waste and heat losses, then hopefully we can start pulling people out of fuel poverty and pulling them along. There's a lot of charities that do a lot of good work, but sometimes it's doing as many people as possible to have some impact rather than doing fewer people to make the maximum impact. And it's a really hard balancing act, and there is no right answer. Otherwise, hopefully we would be doing it. So yeah, you're the academics, you tell us.
I'll just come in as well. I think a very valid point in this as well is what we do with the trade professionals, you know, and very much a case, you know, should we look at, you know, Craig touched on it, you know, these courses to do, you know, size and heat pump systems, should we make it, you know, similar to the gas safe register, where people, you know, installers are registered to be able to fit these systems, you know, and at least that way we'll know that professional will give the best advice possible to the homeowner and not just fit what he thinks is the right thing to do, and then you know, the actual fuel costs of that homeowner skyrocket because it is not the right system.
Yeah, thank you very much. And again, I thank you to all the speakers for the wonderful talks and for the very insightful opinions and the comments. I think this is really a hot topic. As I mentioned at the beginning, also is a very cool topic to talk about heat pumps, talk about heat decarbonization. So it's a huge challenge waiting for us in the near future. So I like to really take this opportunity to thank all the speakers, and also thank you to all the participants to this wonderful session. And I like to keep in touch with Anne-Marie and the ETP. We like to continue this kind of engagement and to promote collaboration between academics and the business stakeholders. And that is the main objective for today. And we like to take this opportunity to really to work with between academics and industrial partners and the business sectors to really make an impact to this very big challenge. So thank you very much. and thanks for coming for this session. Thank you.